Welcome to the video today. We are going to be talking about polar coordinates. So the objective for this is you should be able to plot points in polar form and convert from polar to rectangular and vice versa. So I guess to open this up, normally you're used to dealing with things called rectangular coordinates. And this is the coordinate system. We have y and x. If we plotted a point, kind of makes a rectangle. So this is the rectangular coordinate system. And we have a new, or a different one, called polar coordinates. And polar, you should recognize polar, pole meaning circular. So we're looking at some sort of circular coordinate system. And it really comes down to the angles in this and the radius of the circle. So each of these circles here tells you how far you're going to go out in a radius, and you're going to go starting at 0 degrees here, just like we do in a unit circle. You're going to go this way counterclockwise for your angle. So polar coordinates are given in r, theta, where r is the radius and theta is the angle from 0 degrees or 0 radians going counterclockwise. So if we wanted to, to look at the point 2 comma, let's say pi over 4, then what we do is, the rule of thumb here is do the angle first. I know it's not first in your coordinate, which, okay, it's not, but when we graph them, we're going to look at the angle first, and then we're going to go out 2 units. So in this figure here, pi over 4 is right here. Right, pi over 4 is right in the middle, it's 45 degrees. So we're going to go over to 45 degrees, and this is the line we're going to follow. And from the origin, we're going to go out 2 radians. 1, 2, and that right there is our point 2 comma pi over 4. Okay? So the system that we're using is we're using the angle and then out the number of radians. Let's take a look at a few examples here. So let's go ahead and plot these points. 2 pi over 3. So this is pi over 6, and this is pi over 4, and this is pi over 3. So we're going to go over to pi over 3, and then we're going to go out 2. 1, 2. And there's our point. We'll call that point A. Alright, let's look for point B. B is 490 degrees, so we're going to go to 90 degrees. Remember, this is 0, so 90 is right here. And we're going to go up 4. 1, 2, 3, 4. Remember, we're not going up, left, or right, or up and down anymore. We're going angle and out. Let's call this one C. Pi over 4, so with pi over 4, and out negative 2. So what happens if we're going to go out negative 2 units? Think about it for a second. Yeah, you're going to go out negative 2 means we're not going to go out 2 this way, we're going to go backwards. So we just got to follow this line here. We're going to go back 1, 2 units, and this would be point C. So again, we're going to go to pi over 4 and then go back to 2 radians, I guess, 2 circles. Let's call this one red again. Point D, negative pi over 6. So if you think back to the unit circle, when we went positive angles, we went this way, counterclockwise. Negative angles go clockwise. So negative pi over 6 is right here. And negative pi over 6 is negative 30 degrees, so this is down this way. We're going to go out 5 from there, so 1, 2, 3, 4, 5. And this is D. We'll do one more here. Call this E. Negative 2 pi over 3, which is going to be here. Positive 2 pi over 3 would have been here. So we're going negative 2 pi over 3, and then 2 units. Let's see if we can follow this here. 1, 2. Oh, look at that. D and A are the same point. I'm sorry, A and E are the same point. So it turns out that we can describe the same point in two different ways in using polar coordinates. So, in fact, we could do it more than two ways. We could do it, I mean, we could go around the circle twice if we wanted to in the angle. But we have four principal ways to write 1 point. We can go pi over 3 and then out 2. Or we can go negative 2 pi over 3 and back 2. Or we could have gone all the way over here, which is 5 pi over 3. Sorry, that's 4 pi over 3. We could have gone negative 2 comma 4 pi over 3. Or, okay, so we've got a few options. Or we could have gone this way all the way around that way. So that would be positive 2 and negative 5 pi over 3. So there are four principal ways of writing 1 point in polar coordinates. So I encourage you to get some more examples of, you can make up your own here and just plot points. Okay, let's take a look at the last thing I want to go over, which is how do we convert from polar to rectangular and vice versa. So let's say we have the point 2 pi over 4, and we want to convert that. Remember, these are in r's and thetas. We want to convert that to x's and y's. Okay, so 2 pi over 4 is going to be right here. Instead of going 2 pi over 4, we want to know what the corresponding x and y values are. Well, notice here we have a little right triangle, right? A little right triangle. This is theta. This is r. And if we did the Pythagorean theorem, we would end up with, okay, this is x and this is y. We would end up with r squared equals x squared plus y squared. Right? It turns out that if we wanted to find y, we would just use the cosine. I'm sorry, the sine. So y is equal to r sine theta, and x is equal to r cosine theta. These should look really familiar if you remember vectors or parametric equations of a circle. They look a lot like this. Lastly, we could find the angle theta if we did the inverse tangent. And we want to be careful with the inverse tangent because it might only give us values between 90 degrees and negative 90 degrees. So we got to be careful with that. So we were here, and we're going to. Sorry, I took a little pause here. So these are the formulas that we're going to use, and if we have r and theta, then we're going to use x and y here. We're going to use these formulas to find our x and y values. So let's say we're looking here at r is 2 and theta is pi over 4, and this is our point. We're going to go ahead and say that x is equal to r sine theta, so 2 cosine pi over 4. Remember that x is the cosine in the unit circle, so it just makes sense that we're using cosine here. This is really good for you to know your unit circle, because we're going to be using a lot of these angles and things in the unit circle. Cosine of pi over 4 is root 2 over 2. Okay, so x is going to be root 2 when I simplify. And y is going to be 2 times the sine of pi over 4, which is 2 times root 2 over 2, which is again root 2. So our corresponding x and y coordinate in rectangular form would be root 2, root 2. Okay, so this would be our answer. So let's take a look at how we would take this rectangular coordinates, these in this case, and convert them into polar coordinates. So what we do here is we take r squared equals x squared plus y squared. So we're going to do negative 2 squared plus negative 2 root 3 squared. And that's going to be r squared. And of course we're going to take the square root of that at the end here. But we're going to get 4 plus 4 times 3. And r is going to be the square root of this, so this is 12 plus 4 is 16. We get 4. So r is 4. And we want to find theta. So theta here, we're going to go -2 and down -2 root 3. So that's like somewhere around here. But we could see that the inverse tangent, well, you know what? Instead of saying the inverse tangent, let's say that the tangent of theta, let's say that the tangent of theta is equal to -2 root 3, which is the y, over the x. Okay, and this simplifies to root 3. So what you need to do is you need to find what angle will give you root 3, specifically in the fourth quadrant. And the easiest way to do that is to use the unit circle, and so you got to go back a little bit, and I'm going to assume at this point that you've already done a similar problem like this, and you know that in the unit circle, the corresponding coordinates for the unit circle are going to be root 3 over 2 over 1/2, where this is going to be your y value, so sine, and this is going to be your x value, so cosine, and where your x value and y value is going to be 1/2 comma root 3 over 2. They're both going to be negative, right, because they're both negative. We're in the third quadrant. That's going to be at 4 pi over 3. So we're going to go and say that theta is 4 pi over 3. And again, how do we get 4 pi over 3? You need to look in the unit circle and find where these are your values, because that's where the angle, that's where tangent of that angle is going to be root 3. So you're going to have to do a little bit of review on the unit circle if you need to, because it's critical to do some conversions in polar. So that's as much as we need to do in this video. Again, just to kind of go back and summarize, we've taken, when we plot these, we plot the angle first and we go out the r. And we can possibly write these in 4 standard ways, depending on which way around the circle we're going, and whether we're going back and forth, depending on r or negative r. And finally, we convert from polar to rectangular and vice versa using these formulas here: x equals r cosine theta, y equals r sine theta, or r squared equals x squared plus y squared, tangent theta equals y over x, depending on which quadrant you're in. So if you want to write them in, as you know, go from polar to rectangular, you're going to use the formulas x equals r cosine theta and y equals r sine theta, which should look familiar because they're just like the ones we did in vectors, and we're just like the ones we're using in parametric equations. And if you're going to go rectangular to polar, you're going to use r squared equals x squared plus y squared, and tangent theta equals y over x. And check the quadrant. There you go. Happy day. See you later.